Hi, we're back. I wanted to show you a few other things that are pretty important here that are very useful. One is that we want to make sure that the data fills the full graph space. For a good graph, that's a good idea. And so all you have to do to change the scale here is right-click on the axis. Let me make sure I right-click and go to Format Axis. And then what I'll do is I'll put fixed scales here from 250 to, say, 450 with a major unit of 50. Okay. And that fills the scale pretty nicely vertically. I may have wanted to end at 400 instead of 450, but that's okay. You could do that later if you'd prefer. And then what I'll also do is I'll right-click on the bottom axis and change that scale from 1800 to 2050. And again, use a major unit of 50. And that should give me a pretty good indication there. Now the other thing I've shown on here that I'll get rid of, I'll click on it and delete it, was a linear trend line or a linear least squares fit, the best straight line fit of the data. Obviously this data doesn't fit a straight line very well, but for learning purposes it's a good idea to learn how to make a straight line fit to any set of data. So what I'll do is I'll right click on the data, either one of the data points, and then go to Format Data Series. Add a trend line. And we want the linear trend line. And you've got to make sure to display the equation on the chart, and we'll go ahead and display the R-square value too. And there it is, and I can move it around. And really what this says is that the carbon dioxide concentration is the Y value is equal to 0.438 times the year, and then minus this y-intercept, which isn't very relevant here. And the R-squared value is 0.81, essentially. If there was no hint of a straight line fit, it would be value, and if it's a perfect straight line fit, it would be 1.0. So this isn't too bad, even though it's not very good at all. If I wanted to, I can actually change this to write it as CO2 and put this as the year to be a little bit more explicit there. Another way to get the slope of the straight line, this is the slope or the increase in carbon dioxide per year in parts per million per year, is to just use the function slope. Okay, and what you have to do is put the known y values first, and I'll just select the carbon dioxide values for the y value, separate it by a comma with the known x values, and then hit enter. And I get the exact same value here. This is the increase over the full 210-year period of average increase per year. The nice thing about the slope function is I can change this to just include the last 3 data points by changing this instead of B6, B7, and A7. This will give me the slope then just using those last 3 data points. Another way I could do that is just forget about that first data point and only plot these last 3 and then use the linear fit estimate here. Okay, and likewise I can change this to be just the last 2 data points. You need 2 points to make a straight line, and so just the last 2 rows, row 8 and 9, would also give me a linear increase. Okay, the other thing that you may want to do is jazz this up a little bit more with a title if you want to. This is the basic graph that you would likely need. On your particular one, you do not want to put a linear trend on here, but I just wanted to show you how to do that and show you how to set the scales. That's an important feature. Okay, good.